We're going to work through some practice problems using the fundamental theorem where we are evaluating a definite integral. So remember, a definite integral is where the integral has bounds and we are needing to evaluate that exact area. So we're going to take the antiderivative first. So the antiderivative of t squared minus t would be 1/3 t to the third minus 1/2 t squared. And we're going to evaluate on the interval from -1 to 1. So remember, we take the upper bound and plug in first. So pretty easy to put in the 1 there. And then we subtract and put in the lower bound. And so we've got 1/3 minus 1/2 minus -1/3 minus 1/2. So you can distribute that minus, probably the easiest way to do that. And you see that we get 2/3. Now, on problem number 2 here, I would rewrite this as the integral from 1 to 2 of 3 times x to the -2 minus 1. I think that's going to be easier to take your antiderivative with. So you're going to increase the power by 1. That gives you x to the -1 over -1, and then minus x. And then you're going on the bounds from 1 to 2. So let's simplify our antiderivative first before we plug those bounds in. And now we'll plug in the upper bound first. So I've got -3/2 minus 2 minus, and then put in the 1, that's -3 minus 1. So -3/2 minus 2 is going to give us -7/2 minus a -4. So that becomes plus a +4. So we get 1/2 as our answer there. Now on the third one, I would rewrite this. Actually, I would bring this u to the top. I'd write it as u to the -1/2, and then I would distribute it to this parentheses. It's going to make it a little bit easier with your powers. So notice I have not taken the antiderivative yet. I'm just distributing and simplifying what's inside of that integral to make it easier to do my powers. So I'm going to increase the power by 1, put it over the new power. Again, increase the power by 1, put it over the new power, and we're going from 1 to 4. Now those fractions in the denominator, you're going to flip them and multiply. So I've got 2/3 times u to the 3/2 minus 2 times u to the 1/2. And again, we're going from 1 to 4. So let's put in 4 first. So I've got 2/3 times 4 to the 3/2 minus 2 times 4 to the 1/2. And then minus, now when I put in 1, it's going to be raised to a power. It's not going to matter. So I'm going to just have 2/3 minus 2 there. Okay, 4 to the 3/2, so that's the square root of 4 cubed. So square root of 4 is 2, then we cube it, makes 8. And 8 times 2/3 gives me 16/3. And then 4 to the 1/2 is really square root of 4, which is 2. So I've got -4 and minus, now 2/3 minus 2 would give me -4/3. So I've got plus, plus, that gives me 20/3 minus 4. 20/3 minus 4 is 8/3 there. So well done on that one. Okay, for number 4, we're going to go ahead and rewrite that also. I'm going to rewrite that second one as x to the -2. So let's take our antiderivative. The antiderivative of x would be 1/2 x squared. And then we'll raise the power by 1, making that x to the -1 over -1. And again, we're going from -2 to -1. So that gives me 1/2 x squared plus 1 over x. Always best to go ahead and simplify that antiderivative before you substitute. It makes it a little bit easier for you. We'll put in -1 first. And then we'll put in -2. So -1 squared gives me 1, and that multiplied by a half gives me a half, minus 1. Then I've got -2 squared, which is 4, times a half, gives me 2, and then plus, whoops, minus a half there. Okay, so I've got um, a half minus 1 minus 2 plus a half if we distribute that negative. So a half plus a half is 1, minus 1 is 0, minus 2 is -2. All right, let's do an antiderivative with a trig function. So the antiderivative here would be x minus cosine of x. And we're going between 0 and pi. We'll put in pi first. And then minus, we'll put in 0. Be real careful on that cosine of 0 because it's not 0. A lot of times we use the bound of 0 and we think that everything's going to just turn into 0, and it actually doesn't in this case because the cosine of 0 is 1. So I've got plus plus, so this ends up as pi plus 2 there. Okay, let's look at number 6 then. We'll do the antiderivative. That'll give me 3x to the third over 3 plus 5 halves x squared minus 4x. Really practice with those powers. It's going to make it a lot simpler when you can turn those antiderivatives and simplify them. And now let's plug in the bounds. We'll do the 3 first. And then we'll do the 1. So this is pretty easy when I substitute the 1 in there. Okay, so I've got 27. Let's see, that's 9 times 5 halves is 45 halves minus 12 minus 1 minus 5 halves plus 4. Okay, so 27 minus 12 is 15, minus 1 is 14, plus 4 is 18. 45 halves minus 5 halves is 40 halves, and that's 20. So we end up with 38 here. Well done on that one. Keep practicing with those antiderivatives. It makes it a lot simpler the more and more we do. Now this one we're going to look at a graph, and I'm going to grab a highlighter, see if we can make a little bit of sense of this. So we're looking at the area. Remember, this is when we're given a graph, we're interpreting the integral as the area from -4 to 2. Okay, so I've got a couple of things to consider there, and I might not want to color on this one. I might want to use a pencil so we can show this area. Okay, so we're going to do this area down here, all of this, knowing that's going to be negative, and we're going to do all of this area up here, knowing it's going to be positive. So the area down here, you can divide it up in any way that you want. Okay, I'm going to do a trapezoid between -1 and between -4 and -1, and then I'll do a triangle. So for my trapezoid, first of all, I know it's negative, so I'm going to put a negative on there. My trapezoid rule is 1/2 times the height, which in this case it's laying down, so that's 3. And then I'm going to add the bases. That's -3 and -2. Okay, so actually those negatives are going to take care of my heights, so I don't need this extra negative there. It's going to take care of it. Then let's do, I'm going to do the triangle. So let's add the triangle to it. So my area of a triangle is 1/2 base times height. So 1/2 times 1. And the height is -2, looks like. That's my triangle. Okay, I know the area is going to come out to be negative because of the way I have the multiplication done here. And then I've got another triangle here, which is going to be positive. So 1/2, the base is 2, and the height is 2 as well. So let's add those up. Let's see, -5 times 3 gives me -15. So I've got -15 halves. I've got -2 times 1 is -2 times a half gives me -1. And 2 times 2 is 4 times a half is 2. Okay, so I've got -15 halves plus 1, or that would be -13 halves. Okay, very important. Now I'm going to erase and take a look at the next area. There we go. So our next one, we're going from 0 to 3. So from here to here. So we're going to have that triangle again. If we remember from this part, we already know how to find its area, 1/2, 2 times 2. But now we've got to include this triangle that falls below the x-axis. And so I'm going to do that as a triangle as well. 1/2, and the base would be 1, and the height would be -2. So that gives me 2 plus -1. So we get an area of 1. Okay, let's look at number 9. Then we're going to do the area from -1 to 1. Those look to be the same area, one above the x-axis, one below the x-axis. So we're going to get 0 here. All right, next let's go from -4 to 4. I'm sorry, we're going from -4 to 0. So friends, that's where we're going to do this piece, all of this area down here. Remember, we did that in number 7, but we added a little extra. So these two first pieces are the area that was underneath the x-axis. It's our trapezoid and then our triangle. So we had -15/2 plus -1. That gives me -17/2. Okay. Now look at number 11. Oh, friends, look at number 10. That is not what we were looking for. Let's try that one again. Look at what we were looking for, and I'm going to do it in a different color, make it stand out. We are doing the antiderivative of f prime, which is f between -4 and 0. I was getting a little busy ahead of myself there. So what does that look like? That means we plug in 0 first, and we plug in -4. Now look at your graph. What is f of 0? F of 0 is 0. F of -4 is -3. So we get 3 there, not the area. Ooh, we almost missed that. I almost missed that. Glad we caught that. Okay, look at number 11. Same story. Antiderivative of f prime is f. Now let's plug in our function at 1, our function at -1. Function at 1 is 2. Function at -1 is -2. Notice I'm looking at the y values there, so I get 4. All right, one last one like this. Antiderivative of f prime is f, and we're going to plug in 3, and then we're going to plug in 1. So the function at 3 is -2, and the function at 1 is 2. And so we get -4 there. All right. So we've had some good work here with the antiderivatives, looking at the definite integrals. Now, there are 2 more problems that I would recommend for this particular set, and that is the 2001 question number 5, as well as the 2002 question number 6. Both of these follow along the same topic. What I'm going to do is in the description below, I will link videos that show the solutions to each of these so that you have them. As always, thanks for watching, and let me know if there's something I can help with. If you'd like to see a video of another topic of some sort, I'd be glad to do that. Be sure to like and subscribe. That way you get a notification every time a new video is posted. Bye-bye for now.